Hi everyone, this is Rajeshwari. Today we will be seeing the inferential analysis of placement dataset. We have around 13 questions for doing the inferential analysis for this placement dataset. We will be seeing the solution of them one by one. To start with it, we are importing the pandas library and we are reading the CSV file using read underscore CSV method and we got the dataset here. So we have around 215 rows and 15 columns here. The serial number column is not necessary for the analysis, so we are dropping the serial number column using dot drop method. So we have 14 columns for doing our analysis. So the first question is we need to replace the NaN values with correct value and we need to justify why we have chosen the same. So first we are checking the NaN values in each column using dot is Na dot sum. So here dot is Na, we will check for the NaN values in each column and dot sum will count the number of occurrence of the particular NaN values in each column. So here we can see all the columns have zero values of NaN values, 0 as the NaN values and the salary column have 67 NaN values. So now we are next step we are doing is like we are identifying, we are printing the rows related to the NaN values. We are using dot is Na dot Ne to print the NaN related rows. That is here dot Ne will check NaN value in whichever column NaN value is available. It will check for that and it will print the entire row of the particular NaN value. So here we have 67 rows related to the NaN values. So now we have identified the missing values in the data set. Now we need to replace them. Usually for a numerical column, we will either replace them with mean or median. But here we are having a placement data set. We have status like placed and not placed. So we need to check the status column also for that particular NaN value. So here we have a piece of code for checking that. So we are checking whether the salary column for whichever NaN value is available and the status for the particular column which is equal to not placed. If both of them are true, then we will be getting the output. So here we can see all the 67 rows with NaN values having the status as not placed. So we will not be able to replace them with mean or median here. So we are taking the logical approach. As they are not placed, they will not be having any salary. So we are replacing them with 0. So we are using dot fill a method for the salary column with 0 value and we are giving in place equal to true so that the changes will be reflected back to the dataset. So now once again we are checking whether NaN values are replaced properly in the dataset or not and we can see all the column have 0 NaN values. Next we are printing the dataset out and we are seeing that wherever we have NaN values in the salary column, 0 is replaced here. So the second question is how many of them are not placed. So we need to count the number of students who are not placed from the data set. So for that we are filtering them out with the status equal to not placed from the data set and we are using dot sum for counting the number of occurrence of the students who are not placed. So there are 67 students who are not placed in the data set. We are printing all the 67 rows using filtering the condition with status equal to not placed. So we have here details of the students who are not placed in the dataset. So before going on further, we need to do the univariate analysis for this dataset. That is the main part is we need to check for the outliers. If there are any outliers available in the dataset, it should be replaced by the appropriate value. And then we need to move on further with our analysis. For that, we have a file, univariate file, in which we have all the functions related to the univariate analysis. And we have functions related to finding the outliers and replacing outliers. So we will be using that from this file. So we are importing the class univariate from the file univariate and first step we are doing is like we are separating the numerical and categorical column using using quantqual function. So for that we are getting the quantqual function, we are passing the data set and we are getting both the values here, like numerical columns and categorical columns. So now we have split numerical and categorical, and we are doing the univariate analysis by passing the numerical column and data set. So this function will do the calculation for each column, like mean, median, mode, 25 percentile, 70 50 percentile, 75 percentile, and we have IQR 1.5 rule where upper, min, max, Q, kurtosis, variance, standard deviation. Whatever calculation related to the univariate analysis will be performed for each column. So now we are going to concentrate only on the four values like lower, upper, min, max. This is our values related to the outliers. So once we got the values for lower, upper, min and max, now we are checking whether we have outlier columns, like whether lower outlier or upper bound or outlier is available in the columns for the data set. So here once we run the outlier columns function, and we are getting that lower outlier and upper outlier. So for HSCP column we have lower outlier, and HSCP degree P salary column we have upper bound outlier. So now we have identified the outliers available in the available in the columns. So we need to replace them with appropriate value. For that we have a function replace outliers. We are giving the necessary parameters for the function. We are running it. Once we run it, we need to check whether it is getting replaced or not. So we can take HSCP as an example. So as it has both the outliers, lower and upper. So this is the HSCP column. We can see the lower bound is 42.75, upper bound is 91.15, min value is 37.0, max value is 97.7. So here we can see the min value of the HSCP column is less than the lower bound of range 42.75, and max value of them is greater than the upper bound. So 97.7 is greater than 91.5. So this should be replaced once we run the replace outlier function. So we are checking that now. So here we can see that the mean value and max value are replaced based on the lower bound and upper bound 42.75 and 91.15. So now we have replaced all the outliers available in the data set. So now next step will we are checking once again whether the outliers are available in the columns or not. So we are running once again, we are running the outliers column function, and we are getting the empty list. So we are good to go. So the next question is we need to find the reason for non-placement from the dataset. So for that we are starting with the numerical columns. We are grouping them by status using group by and finding the mean of the numerical column. So here we can see we have two status, not place and place. We have the mean for all the columns, all the marks column and salary column. We will not be taking the salary column as for not placed, we don't have any salary. So we will not be taking the salary column for analyzing the reason for non-placement. So the other columns, we are taking other columns. Based on the other columns mean for not placed and placed, we have these observations below. So students who got average marks of 57 to 70 percentage in SSCP are not being placed, and students got average marks 58 percentage to 68 percentage in HSCP are not being placed. Students who got average marks of 61 percentage to 67 percentage in DDP are not being placed, and students who got average marks from 70 to 72 percentage in entrance test mark are not being placed. If we see the MBA marks, we don't have much difference between them. So not placed, we can see 61.6, which is nothing but approximately 62, and for place it is 62.5. So there is no huge difference between average of students getting the average marks of MBA for students in not placed status and average marks of MBA students in placed status. There is no vast difference between them. So we will not be able to get the reason for not placed here from MBA marks. So next we are moving on to the categorical column with placement status. So first we are taking the gender column with placement status. Here we are grouping them with gender and status using group by, and we are using dot size and unstack. This size will count the number of occurrence with respect to gender and status, and this unstack will print the result in a tabular format. will take the result out in a table format. So we are printing it out. We can see out of 76 women, 48 are placed and 28 are not placed. That is around 36 percentage are not placed. Out of 138, out of 139 men, 100 are placed and 39 are not placed. That is around 28 percentage are not getting placed. So by saying this, we can say women are likely not getting placed compared to men. So here we have a count plot using Seaborn for the same result, like placement wise gender, like placement status by gender, that is gender wise placement status. By grouping gender and placement status, we have the count plot for placed and not placed. So here placed is blue color, orange color is not placed. So the next column is SSEB column, 10th board, which have two categories, central and others. We are grouping them in a similar way how we did for gender and status. Here we are grouping them by SSCB and status. We are using the same method like dot size and dot unstack for getting the result out in the tabular format. So here out of 116 in SSCB central, 38 are not placed. Out of 99 in SSCB others, 29 are not placed. So in SSCB central, 32 percentage are not getting placed. In SSCB others, 30 percentage are not placed. So comparatively, students in SSCB central are likely not getting placed compared to students in SSCB others. So this is the SSCB wise placement status part. We are plotting them using C1 count plot. So the next is the HSCB wise placement status. We are using the same group by size unstack functions to display the result in a tabular format. So here out of 84 in HSCB central, 27 students are not placed. That is around 32% are not placed. Out of 131 in HSCB others, 40 students are not placed. That is around 31% are not placed. So here again we are having the plot for HSCB wise placement status for placed and not placed. And from the percentage of not placed, we can tell that HSCB central students are likely not getting placed compared to HSCB others. So the next is HSCS based placement status. We are doing the similar way. We are having three categories in this: arts, commerce, and science. So out of 11 in HSCS arts, 5 are not placed. That is 45% are not placed. Out of 113 in HSC commerce, 34 are not placed. That is 30% are not placed. Out of 91 in HSCS science, 28 are not placed. That is around 30% are not placed. So we can say that students in HSCS arts are likely not getting placed compared to students in HSCS commerce and HSCS science. So here we have the count plot for the HSCS placement status. So the next is we having the degree T wise state placement status. So we have 3 degrees: commerce and management, others, science and tech. So out of 145 in degree T commerce and management, 43 are not placed. That is 30% are not placed. Out of 11 in degree T others, 6 are not placed. That is 45% are not placed. Out of 59 in degree T science and tech, 18 are not placed. That is 31% are not placed. So here we have the count plot for the degree T wise placement status. So we can say that students with degree T others are likely not getting placed compared to students in degree commerce and management and students with degree science and tech. So work experience wise placement status. We have a work experience yes or no. For that we have the placed and not placed count here. So out of 184 in work experience no, 57 students are not placed. That is 40% are not placed. Out of 74 in work experience S, 10 students are not placed. That is 14% are not placed. So we can say that students with no experience, no work experience, are likely not getting placed comparatively to students with work experience. So we have the count plot for work experience wise placement status. So the next column is specialization column. So we are grouping by specialization and status using dot size for the counting the number of occurrence and dot unstack for the tabular format. So here we have two specialization, market and finance and market and HR. So out of 120 in the specialization market and finance, 25 students are not placed. That is 21% are not placed. Out of 95 in specialization market and HR, 42 students are not placed. That is 44% are not placed. So we can say that students with specialization of market and HR are likely not getting placed compared to students with specialization of market and finance. So we have the count plot for the students for specialization wise placement status. So the overall observation for not being placed in the categorical column is women are likely not getting placed compared to men, and students in SSCB and HSCB central board. Central board students in SSCB and HSCB are less likely to get placed compared to other boards, and students from the arts in HSCS are less likely to get placed compared to commerce and science. Students from other degrees are less likely to get placed compared to commerce management and science and tech. Students without work experience are less likely to get placed compared to students with work experience. So students with market and HR specialization are less likely to get placed compared to students with market and finance specialization. So the next question is we have need to find the relationship between salary and MBAP. So first we try to get this relationship using a scatter plot, having x-axis as MBAP, y-axis as salary, data as the data set. Here we are not able to find any relation between MBA marks and salary. That is, there is no zero or no correlation between MBA marks salary. We are not able to find any upward slope or downward slope here to say that we have positive relation or negative relation. So there is there is no correlation or zero correlation between MBA marks and salary. Whether in MBA marks are getting increased, salary is not constantly getting increased or decreased. We can't find the particular relationship between MBA marks and salary. So to understand further, we plotted a line plot using C-bond. X-axis as MBAP, Y-axis as salary, data as the data set. Here we can see the salary is getting increased for few data points and it is getting decreased for few data points. It's like to and fro, increasing and decreasing. So we are not able to tell a particular relationship between them. So the next question is which specialization is getting minimum salary? For that we have a function find specialization minimum salary and we are passing the data set. So here first to check where first line of code like first we need to say see whether the students are placed or not. So for them only salary will be available, right? So we are checking the status of the students which is equal to placed. So we are taking those rows to this placed students. So once we take the students with placed status, from them we are checking the min salary using dot min function and we are taking them to min salary. So and we are printing the min salary, minimum salary of the placed students, min salary. So once we find the min salary, we are taking the min salary rows, the rows of the minimum salary to min salary rows. Like we are verifying each row of the salary column by equating them with min salary. So whatever row have the minimum salary will be taken and we'll having it here. We'll be checking each row of the salary column of the placed students and we will be seeing whichever row satisfying this condition which is equal to minimum salary that will be taken to min salary rows. So once we have the min salary rows, we are taking the specialization and salary from those rows and we are printing here. As we need to find the specialization which is getting minimum salary, we are taking only the specialization and salary value from the min salary row using a for loop and we are taking and printing it out here. So we are running the function by passing the data set. So first we got the minimum salary of the play students in this data set is 2 lakh, and we are printing them with specialization. So here we see 3 rows have market and finance as specialization, and 3 rows have market and HR as specialization. So there are 6 students who are getting minimum salary, 3 each from market and finance, and market and HR getting the minimum salary. So students with both the specialization are likely to get minimum salary. So we are not able to predict whether market and HR students or market and finance students are getting the minimum salary. Yet both of them are equal. So students with both the specialization are likely to get the minimum salary. So how many of them getting above 5 lakh salary? For that we have a function, find students with greater salary. We are passing the data set. So first check we are doing it. The first step is salary greater than 5 lakh. That is, we are taking the salary, values of the salary, and we are checking whichever values are greater than 5 lakh. So we are taking all the values from that, and we are keeping it in salary greater than 5 lakh. And next thing is we are counting the number of occurrence for salary which is greater than 5 lakh using len. So we are keeping it in number of students greater than 5 lakh. So this will be the count of the students who are having salary greater than 5 lakh. We are returning both the values. So once we call the function, we are taking both the values from the function, and we are having this variable, and we are printing it out. First, we are printing the number of students getting salary greater than 5 lakh. That is number of students we are taking from the function, and we are printing the rows who are getting all the details of the student getting more than 5 lakh. So here we can observe that students with market and finance specialization are getting more than 5 lakh as salary. So the next question is, we need to test the analysis of variance between entrance test marks and MBA marks at significance level 5%. We need to make the decision using hypothesis testing. So for that we are importing scipy.stats, and this is ANOVA one way as we are doing the analysis of variance between the columns. So it is ANOVA one way. We are taking the function f underscore one way for performing it. We are passing the entrance test mark and MBA marks for which we need to perform the analysis of variance. So we are getting the value, output value, statistic and p-value. Now we need to do the hypothesis testing. Here we are having H naught as there is no significant difference between entrance test P and MBA P marks of the student, and H1 as there is significant difference between entrance test marks and MBA marks of the students. We need to reject the null hypothesis if P is less than 0.05. Here P value is, we can see that exponential to the power minus 21. So it is like 0.00004672, which is definitely less than 0.05. So we are rejecting the null hypothesis H0 and accepting the alternate hypothesis H1. So there is significant difference between entrance test mark and MBA marks for the students. Next, we need to test the similarity between degree T science and tech and specialization market and HR with respect to salary at significance level of 5%. We need to make decision using hypothesis testing. For that, here we have two groups, degree T of science and tech and specialization of market and HR, and same condition, that is salary. So it is independent part T test. So we are importing T test underscore IND from scipy.stats. So the first thing is we need to take the degree T with size and tech filter, and with salary we are keeping it in degree T, and specialization with market and HR with salary, and we are taking it to specialization. So now we are running the function T test underscore IND using the variables which we have it previously. So degree T and specialization, we got the statistic and p-value here. So here we need to check the hypothesis testing. So we are having null hypothesis as there is no similarity between salary of degree T science and tech and specialization market and HR students. Here we will be rejecting the null hypothesis if P is less than 0.05. So here the P value is 0.007, which is less than 0.05. So we are rejecting the null hypothesis and accepting the alternate hypothesis. That is, there is similarity between salary of degree T Science and Tech on specialization, market, and HR students. The next question is, we need to convert the normal distribution to standard normal distribution for salary column. Here we have a function. We have written a function std and b graph. We are passing the data set. So once when we know that we need to do the standard normal distribution is like, it's nothing but we need to find the z score. So z score formula is x minus mean divided by standard deviation. So for that we need to have the mean value and standard deviation value. So we are importing Seaborn for plotting the graph, and we are calculating mean and standard deviation using mean and std function. And we need to get the values. So here we have the value as salary column. So from salary column, we need to get all the values available in the salary using a for loop, and we need to keep it in the values list. So once we have the values, we are passing it to the next step for calculating the z-score. The z-score should be calculated for all the values available in the values list. So z-score for all the values are calculated. Once we calculated all the values, once we calculated the z-score for all the values, we will be plotting it using a disk plot. We are passing the z-score value, and we are having KDE equal to true to have the curve visible for us. So now we are running the function by passing the salary column, for which we need to do the conversion. We got the output. So the next question is, we need to what is the problem? We need to find the probability density function of the salary range from 7 lakh and 9 lakh. So this we have a function. We have written a function here, get PDF probability. We are passing the data set, start range, end range. Here the start range is 7 lakh and end range is 9 lakh. So now we are importing the libraries for plotting, for matplotlib and seedborn for plotting. And scipy.stats, from scipy.stats we are importing norm. Here we are finding the probability value with normal distribution. So the first step is we are plotting the plot using this plot, and we are passing the data set. We are having the curve visible to us, and the curve color is red and the histogram color is green. So the next one is we are having XV line here using the ASV method, XV line method. We are trying to plot or like trying to draw two vertical lines for the start range and end range. So we are using AXV line function. For start range, we are giving the color equal to blue, and for end range also we are having a vertical line. So we are having AXV line, end range, and color blue. So we will be getting two lines in 7 lakh and 9 lakh. So next, the sample is nothing but our data set, and we will be finding the mean and standard deviation. So we will be passing them to the normal function. So we are calculating the mean value using dot mean, standard deviation by the s.std function, and we are taking it to these two variables. And we are defining the distribution by calling the function norm, and here we are passing the mean value and standard deviation value. So once we define the distribution, the next step is we need to take the values. We need to take the values in such a way, whatever values are available between the start range and end range. So whatever values in the salary column between the start range 7 lakh and 9 lakh will be collected and will be kept it in the list values. So once we have the values, we are finding the probabilities for all the values using for loop. So for all the values, we are identifying the probability, and we are having it in the probabilities list. So once we have the probabilities list, we are summing all the probabilities values, summing it up, and we are keeping it in prob. So we will be returning the prob. So once we call the function, we are passing the data set with salary column, for which we need to find the probability from a start range 7 lakh and end range 9 lakh. So here we got the result, mean and standard deviation, which we are displaying here, and we have the prob value 0.004, and we have the graph. So here we can see we have the vertical line from 7 lakh to 9 lakh, and here we have the prob value 0.004. There is a 0.0004 possibility of getting salary from 7 lakh to 9 lakh. So the next question is we need to find the similarity between degree T science and tech and with respect to entrance mark and MBA mark at significant level of 5%. We need to make decision using hypothesis testing. So here we have we have say one group with different conditions like different marks. We need to find the similarity here. For that we are importing t test underscore rel from scipy.stats. So once we have that, we are taking the entrance test P as for by filtering the degree with science and tech with entrance test P and taking it to test P, and we have degree as science and tech with NBAP and taking it to NBAP. So now we are running the function t test underscore rel with the before values like e test P and NBAP passing the values. So we got the output statistic value and p value. So now we need to check the hypothesis. We need to make the decision using hypothesis testing. For that, we are keeping the null hypothesis as there is no similarity between entrance test mark and MBA mark of students with degree science and tech. We will be rejecting the hypothesis, null hypothesis, if p is less than 0.05. Here the p value is 0.00. We can see here exponential to the power of minus 6. So it is 0.000555179, which is definitely less than 0.05. So hence we are rejecting the null hypothesis and accepting the alternate hypothesis. So the next question is we need to find which parameter is highly correlated with salary. For this, we have used of core function having numerical only equal to true. So we have all the correlations in the data set, correlation values of all the columns in the data set. So here we need to concentrate on the salary column. We can see that comparatively SSCP column, SSCP is highly correlated with salary, that is 0.558. So now we are trying to plot a graph for that to explaining it. First, we are having a heat map between for all the columns in the data set. Here we can see that only the SSCP column for salary is having the highest correlation in the data set. To understand further, we have drawn a scatter plot between SSCP marks and salary, having an x-axis as the SSCP marks and y-axis as salary data as the data set. Here we can see a slight upward slope for few data points in the graph. So it's like it's not neither 0 nor 1. It's like 0.5, right? It's in middle. So we can see a light upward slope here. So to understand further, we have the line plot for SSCP and salary column. And we can see for some points, whenever the marks are getting increased, the salary is increased. But for some points, when the marks are getting increased, the salary is getting decreased. Comparatively, we have the high correlation for salary column is with SSCP marks.